I don't know what's going on with my camera, but it is Tuesday, March 19th. So hopefully we getting it in. Get all that stuff in your agenda. We are going to do a couple of things this week. So one, we are going to have the practice state test on Friday, just as a reminder, right? And basically if you take it, you'll get, and do your best, you'll get 100%, which means you'll get basically 100% credit for a quiz. On the flip side of that, if you don't take it, which is totally fine, you're not here because some people are going out of town, yada, 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 totally fine. That just means for you, you will not, you will get a 0 out of 0, which won't affect your grade at all. So just like that. It's either you take it or you don't. Like, because I can't set it up, like, in all the privacy stuff without, you know what I mean, without like having the whole class do it. So it's either you're here or you're not, and that's just how it is. So I did want to put that out there. Also, 3 weeks progress reports will be printed and they will be given out tomorrow. So that's Wednesday, and then on Friday you need to bring them back. So you bring them back on Thursday, I get your credit. Friday, get your credit, extra credit. If not, it is what it is. Also, anyone who has a lower than 70% grade, I will be messaging your parents directly and being like, hey, yo, this is your student's progress report. Like, let me know what I can do to support them. I am concerned because I'm going to keep it real. I'm going to kick it on here. Y'all going to 9th grade next year. And I'm like, yo, is this how we finishing? Because I'm like, habits are hard to break, especially if you've had them for a long time. So I'm like, look, even if you have had bad grades the entire like 6th, 7th, and 8th grade, doesn't even matter. None of that matters now. Only thing that matters is what do you do right now with this next choice. So I'm just keeping it 100. Like, you got an opportunity right now. It's the awesome thing about every day. Every day is a gift where you can make a brand new choice and make the right choice going forward. So please, like, start some new habits, because that's what you want as you head into high school, as you head into 9th grade. So I'm just putting that out there. Trust me, I didn't see a lot of students who were like, but they started like getting themselves corrected. And I'm gonna be honest, some of them still got F's, but they start getting themselves corrected, right? During that 3rd trimester, and then now in high school, they go, shh, you know what I'm saying? And that's what I want for you guys. Like, if you find yourself in that situation. And then for those of you who are like, oh, I'm tired, finish the race. You know what I mean? Finish the race. All right, y'all, let's move it forward. So, there was a skate park. We kind of talked about this yesterday and went over all of the things yesterday as well. So let's just look at these questions real quick. I think I have it on the next page. Yup. Let's just look at the questions. So in class, we're just going to give time to get this finished. So if you need time to get this finished, go ahead and get this finished. Just as a reminder, I added that you need to do 3 ramps, and then you just need to make observations about kinetic energy. Just point out, like, hey, where's the highest amount of kinetic energy? Where's the highest amount of potential energy? That'll be cool if you do that. And you need to draw those 3 ramps down there. I will show you what this looks like. So hold up. Back to this thing, and I think what we're gonna do is see if maybe we can put these jokers side by side. Put the presentation, maybe not. Let's see. Oh yeah, we might be able to do that. Yep, and then get this joker on over here. Let's see if we can scrunch this guy up. See. Oh yeah, buddy. Yeah, buddy. There we go. Okay, got that buddy right there, and then we'll go back to here. Oh, and those look super small. But let's just take a look, and maybe we can present and unpresent. So as we look through these questions, right? Oh, you know what we could do? Hold on. I got an idea. We can just bop. Yup. Come on. Look at your boy. So look, we're gonna go ahead and put the skater on there. We're gonna click the pie chart just like they say, right? And then click the speed graph as well. I'm gonna put the bar graph because I like it. I think it's easier to read than the pie chart because it's labeled and it's going up and down. So as you're looking at this, what do you notice about the speed? And if you notice, the speed is going down and then it's going up, down and then up. So put what you notice about that. Also, what does the color change represent? So there's some sort of color change going on there and there. What is it? It's something about transfer or something between kinetic to potential. So hopefully you write that in right there. Number 9, let's look at that. Describe the speed and energy of the skater when he reaches the bottom of the ramp. Now the crazy part, it says put it in slow motion. So I'm gonna put it in slow motion. So as it gets to the bottom, what I notice is, 1, speed seems to be at a max, because right after this speed starts to go down, and then I also notice my potential energy seems to be at a 0 and my kinetic energy seems to be as high as possible. So those are the things that I notice. See, See how speed's going down? See, that's what I noticed. Okay, let's move myself over here and look at these next set of questions. I'll move myself down. Okay, so describe the speed and energy as a skater as he reaches the top of the half pipe. So let's talk about that. So watch the speed. Speed looks like it's going down, and then, so I'm gonna pause it right there. So speed looks like it's going all the way down, like almost to its lowest. Kinetic energy now seems to be all the way down, and potential energy seems to be as high as it possibly can be. So what does this simulation demonstrate about the transfer of potential energy to kinetic and then back again within a system? So first of all, what is the system? So hopefully you're like, oh, I remember systems, some parts, some things, interrelated objects, right? Some interacting objects. So that would be like the skater, the skateboard, and the ramp. Yeah, those would be are the things in our system, right? Those are the things in our system. And then, right, so how does this simulation simulate or demonstrate the transfer of potential to kinetic energy? So think about it. Like, what's happening? When is it transferring to kinetic to potential? When is that happening? When is it transfer from potential to kinetic? And how does this go about demonstrating that? What do you guys think? So think about it for a second. See what you can write down and then come back to this page. So hopefully you notice it seems like it's traveling at its highest speed and has the most kinetic energy when it's going down, or it seems like it has the highest speed when it has the most kinetic energy, and it seems like when it's at its highest point, so as high as it can go, then it has the most potential energy. That's what I see about the transfer. That seems like how it's demonstrating, like, potential energy really, especially gravitational potential energy, has to do with the height of an object, right? A lot, where kinetic energy and it seems to have more to do with the speed that the object is actually moving. So hopefully those are the things that you got up out of there. All right, let's move it forward. So let's just talk about this for a minute. Now, we've talked through both of these, kinetic and potential energy. We've walked through this before, but let's just talk about it for a second. I'm just going to go ahead and put it up here on the screen. So I want you to write all of these things down, okay? Write all these things down. So kinetic energy is equal to half, which is the 0.5, okay? And, oh, by the way, write this down, in your journal over there. Write this down in your journal, okay? So again, the half is equal to 0.5. The m is equal to mass, and that's in kilograms. And then the velocity is equal to speed. And just as a reminder, speed is equal to distance divided by time. So that means if you're trying to calculate velocity, you would calculate it distance divided by time. Mathematically, again, velocity and speed are equal to each other. I just want to get that out there. Mathematically, they are equal to each other, and it would be this distance divided by time, okay? So whatever the distance is, and a lot what we've been using in science is meters per second. In the United States, the one we like to use is miles per hour, right? Okay, so then if you look at potential energy, very similar. The mass, right? Both masses are in kilograms. So the m is for mass. Both of them are in kilograms. The G is for gravity. Hopefully you guessed that. And the gravity is, and I'm going to zoom in right there so that you guys can see that. Zoom. We're going to zoom right on in. Oh, I don't want to put my little mark on there. But it's at 9.8 meters over seconds, and the seconds are squared, okay? So just as a reminder, when you're putting this stuff into the calculator, you're just going to use the number, the 9.8. This one's a little bit different because it's a constant, so the number's already given to you. This right here is the units, just like we say meters or kilograms. Meters per second squared is the unit. So I'm going to try and clarify just a little bit. What I'm going to do is I'm going to, let me see, where's my little, oh, there we go. So let's see if we can just, that might help you guys in your thinking or in your logic, okay? And then the H stands for height, and as we just looked at from the skateboard, the higher it is, then the more potential energy there is, and the height is in meters. So I'm gonna go ahead and zoom back out. Make sure you have all of these notes inside of your journal. Yes, make sure to label everything. This should probably take up about half a page. If you do it really small, it's going to be really hard to label everything. This is exactly how I did my notes in college. It helped me out so much because I always would understand what each letter meant. And the thing is, as you get more and more formulas, right? More and more formulas, for me in my brain, it was hard to like know what each letter meant. So I'd always write it out, and it would help me also memorize it quicker. Okay, so I'm gonna go ahead and put that back down. We up out of there. This is basically a breakdown of the same thing. Okay, easy breakdown of the same thing. Right, easy breakdown of the same thing. I don't like to write it like this. The main reason is because I'd rather write it on top of the formula. You don't have to take this as a note. This is just for your brain to be like, yo, it's the same thing. So mass for both formulas in kilograms. Potential energy has gravity and height. Those seem to be massively important. And if you look, kinetic energy has to do with velocity. And that plays right into that final question on the skateboard, right? This fact that kinetic energy is the highest when velocity is at its highest or speed is at its highest, and then potential energy seems to be at its highest, right, when the height is very high. The higher it is, then it seems like the more potential energy we have. Okay. Cool. So you guys are going to go ahead and start this. For the folks that are at home, okay, for the folks that are at home, I'm going to connect this worksheet inside the module, okay? Inside the module, I will connect this worksheet so that you can get started on it. And then what you're going to need to do is probably write it in your journal, because if you're at home, there's not a, I'll have, the PDF will be in there, so you can print it if you can print it home. But if not, you're going to have to start this whole thing and put it inside of your journal. Sorry, I know it's some writing, but just make sure you do 1 through 8, okay? 1 through 8. So this is what we're going to be working on today, and then, tomorrow, and then we'll go over some of the questions. All right, y'all, have a wonderful day. Get started on this, because several students got started on this. Every class is a little bit different, but we'll be working on this tomorrow. All right, y'all. Peace. Oh, whoops. Peace.